the National Technology Award Param for developing a parallel computing flight simulation system. He was awarded the Summer Fellowship by the National Space University for Space Project Design Program in Toronto in 1990. He is recognized as a leading multidisciplinary expert with strong computing background. He authored and published about 165 research papers in computing and multidisciplinary fields, and he promotes cross-domain fusion of knowledge. He was the chief editor of journals Intel-GRI Science and Technology and Intel-GRI Computer Science and Networking, published by Interline Publishers. He received the Team Tech Foundation Award for Excellence in Education and Research in 2009. He has several patents in the field of computers and communications. So it's a long CV. Thank you.
Ladies and gentlemen, at least ladies and gentlemen. So it's a fine evening, and it's a pleasure to be associated with these guys, and especially with the Professor Orhan, who was actually talking to me about an opportunity to come to Middlesex and then talk to me, and then Ali, who was actually prompting the whole show, said we are going to have a conference shortly. Would you be able to find time? I said yes, but it so coincided the dates such a way that, you know, I was actually in the eastern part of the world. To be so, for a sphere, how east and west is defined, you don't ask me. So the people said this is east and this is west. So I was in Bangkok 2 days back, and then I flew down. It took exactly 24 hours, and then took towards the left side from the middle point of Bahrain. So that's how I entered here, and then we had a mess up in the morning because of the line losses. So I had to take a little bit rest. So that's how I entered in a very typical condition here now. So with this brief introduction, I am going towards the subject. We have enough heard about cloud computing, and many of you are working in cloud computing too. And the cloud computing has taken its wings and spread its wings, and then now flying with hi-fi. Many of the leading companies supporting it, many aspects of it, whether it is the PMS matrix, actually the processor, memory, storage matrix, to be actually configured, reconfigured, and then produce different structures by which you will be able to, on demand, you will be able to create the computing needs as you like it, and the way in which, you know, the clouds can be integrated, and it can be reconfigured, it can be disposed. So reconfigurable and upgradable and disposable systems already we have achieved. There are several models, and there are several access methods, there are several metering methods, there are several configuration methods, there are several types of issues even associated with many of the aspects I talked to. So the resilience, the security, and the provisioning, some of the basic issues of that is still getting resolved. And new models are coming. Some of the papers are touching upon those new models. At the same time, you must be aware that the whole business, the way in which they support the computer science and computer engineering for the last 50 years. So when the computing was bound in the scientific laboratories in the 1960s and 70s, and probably to some extent of 80s, there was no surge actually. The support was mainly from the business side, which made to proliferate the computing technology to the extent what we have today. So the money getting pumped in is because of the support what we offer to the business community. They have a lot of business process, whether it is Walmart or whether it is Siemens or whether it is actually the Nissan Motors. So these people, they want to make use of the science and the engineering what we develop. And one of the aspects of that is the current thoughts are how effectively they can make use of the cloud. And then the cloud features are naturally coming in. And we are going to profess about it, and how you can transform your enterprise computing, which is actually edified on the business structures of the successful companies, unsuccessful companies too. So based on that, how will you be able to transfer your enterprise computing into the cloud architecture and the cloud methods? This is what we are going to talk to. And as I said, the cloud computing was here for a long time. The long time, as far as computers are concerned, it's of the order of 1 or 2 years or even 6 years. It's really a long time. It's not, we are not talking about the human age or the age of the earth or the age of the universe. So in that way, cloud computing was here for some time, or much pretty way in the scale of actually the computing, much longer time now, from maybe 2008 or 2007 in the practical ways. So you can see the basic fundamental structures where you people are familiar with. We have actually the cloud architecture in the middle portions of it, and then we have the enterprise architecture available, enterprise architecture here, and the cloud structures, the general ones. And we want to migrate actually the cloud migrating into the enterprise environment, or the enterprise getting bunched up with the cloud. So these two processes, how successfully we can do with the existing technology and filling up the technology gaps what we are going to project. So there are two requirements. Today what's available is a wonderful thing actually. Many of the companies actually, not only VMware or not only HP or not only even Microsoft supporting in different ways, and many companies have come up with their own solutions, and then that can be imparted into many of the successful cloud centers, or the old data centers got transformed and then claiming to be the best one in the world by everybody. So in that attitude, or in that scenario, how the enterprise computing, which need to be absolutely secure and which need to be absolutely resilient to breakdowns, which need to be 24 hours and 365 days up and running without any problem, and on demand the power must go up, and then it should be actually absolutely reliable in computing, not only availability. The reliability of the computing must be in the software side, hardware side, usage side. Many of the listings, 7 listings we have, it has to be complying with all the requirements enterprise computing is projecting. So the growth and diversification of computing technology, as I was telling actually several times, took a dramatic turn, which these things are quite known to you. It may be good for a student to look into, but for us we know that it is a fact by itself. And getting the Internet of Things, we will integrate all the IPs available in the world, and then we'll make a network by which the transportation of messages will take, and then form a cloud intelligence even with that. Apart from that, actually, when we look at the topic of the day, the enterprise computing, we are going to see how the transformation reliably could take place by which the marriage of these two, which has already taken place in a limited way, with a lot of suspicions and then a lot of reservations, companies expressing, but they migrate a little part of it, another part. It provides reconfigurable, quick, upgradable, and disposable computing resources, what we say. So now let's move on to the next one, and cloud as a service. So when the resources are accessible with a request structure, well, that's what cloud is actually. The various reorganization of resources can produce variety of services. That's what makes actually the cloud existing today, because it meets many of the perceptions what we have about the computing. We cannot buy the whole thing. We cannot buy actually a 10 million or 20 million or 100 million or 200 million based on few $billion turnover to maybe 350 or 400 million dollar of Walmart. So that's scaling up. We have to invest the whole thing actually, the hardware and software, and then start doing the thing. So we want actually the resources specifically getting identified, and then we acquire it, use it, and then give it back. So for that purpose, definitely you will be getting the software as a service, platform as a service, and infrastructure as a service. So the deployment can be private cloud, public cloud, and community cloud, and hybrid cloud. So we have defined, redefined, and upgraded definitions are available over this. So you can look into that, several types, but it has got an aim actually. Say for example, infrastructure as a service. So when we define and redefine and then make it very, very sharp, but the fact remains to be the infrastructure must be made available for me to do the computing successfully and relieve it. So that aspect, so whether it is service or it's a platform for development purpose, everywhere better definitions and then better orientations have already come. The enterprise find this transgenic computing environment as a green field for migration. So this is a point actually. CEOs may be actually in a position, they are a little perplexed actually because of the anonymity of many things inside. That's one factor for them. And the lack of security as they perceive, because they are not able to touch and feel the security, what we are actually talking about, the cloud computing. So they are, parametrically they want to analyze, and they want to have the touch and feel of it, then only they will be able to. But we have seen that the attitude is, it is considered as a green field for migration. Client and enterprise computing. Now when we want, they have got branches everywhere in the world, and they are actually the producers also. So the business process is actually taking the nuts and bolts and then creating a car and disposing it maybe in Dubai or in probably in Melbourne or maybe in Washington DC. So the business process of realizing things and then getting translated into the software and then operating it. So that enterprise business computing we want to transplant from the custody-oriented computing platforms, or the most secure, we call it, because I can embrace it and hold on to my chest, so it is totally secure, we feel. But it's not so, though. So the enterprise need robust technologies, always they will talk about you, or robust technologies and developmental environment to create enterprise software. We know that, we were doing it, business process. So whether that company, the petroleum company, or the company in Japan, or in some parts of the United States, so whether it is a big company or a small company, they have got this definition, how the enterprise computing has to be. And now, transplanting them into the cloud, what are the challenges? Let's have a look. Traditional data centers, and before we start migrating, let's have a look, actually, the cloud, and it's a viewpoint by which cloud is looked at, how suitable it is for the enterprise computing. So the old data center, we have transformed it into the cloud. Through which way? It's an easy mapping, actually, what you are seeing. We have the firewall, load balancer of the resources, what we can use, in that several resources, and we have the storage. And this quarterly unit was working in the past as the data center, but we slightly transformed it so that the services are actually packed, which can be configured and reconfigured. Or it can be upgraded and it can be even disposed also, which we don't want. So we go into the hypervisor or the virtualizer technology by which we can crisscross, connect, and then form things. Okay, so we got the computing and the network storage, we put this, and then the cloud basic concepts are ready. So this is what we are going to depend on the right side, how we will be able to map it and then do it. So before we get in an increment with accepting the cloud and then transporting it from my company environment to the cloud environment and feel that the company is secure in the cloud, we have to have the idealized the definition by which the agreement has to be signed. We have to have the perception the correct way. Let's have one look actually how NIST has defined. Cloud computing is a model for enabling convenient on-demand network access to a shared pool of configurable computing resources, like all the things what is listed there, that can be rapidly provisioned. So now the issue starts of questions shoots there in the definition itself. So with minimal management effort or service provider interaction, when the thing is that if you have established an enterprise edifice in your company, you don't require anybody else's support to make use of it. Will this be realized? So with minimal service provider interaction, that means a cloud is reflected into my enterprise. It must be available to me as free as it is available today from the corner of my building. So we have built up and refined this into this level, thinking all those aspects of it. Promotes availability and is composed of 5 essential characteristics, which I will be 3 service models with which we were pushing actually the cloud into practice. And then the resource pooling, all the resources we can pool, and then we will be able to distribute it in a reconfigurable way. And the cloud resources are pooled into, of course, that's what I was talking about. And the rapid elasticity. This is actually quite recent in the sense of the order of 1 or 2, 3 years. Actually, when we introduced, one of the initial papers are from me, actually, processor and memory and the storage matrix, how this matrix, M cross N matrix in everywhere, this matrix can be coupled and then can be configured, so they are becoming the pseudo machines, which definitely, by the side of it, actually, VMware is doing an excellent job here and in California. An invitation is there to discuss with them in new ideas. So the rapid elasticity, so I will be able to expand it and contract it depending on the requirement is actually increasing or even decreasing. Decreasing things we have not seen much in computing science. If you are buying a computer, next day your software will build up such a way that that infrastructure is not sufficient enough. This is the crisis which is going actually. So people will be building up an infrastructure and they will add the software to that. They operate for a while and the company will be actually building up another infrastructure much faster than the earlier one. They will build up a software, they outperform the earlier one. So this competition is actually continuously building up. That is true with any intelligent system, so to say, because my field is the other one too. So any intelligence if you build up, the comparative intelligence build up on the other systems will be much better than the original one which is actually reflecting the intelligence. So it happens with the information technology too. That is the growth factor. When that becomes actually 10 to 0, the growth will be nil. But that's not the fact actually. Right from the biological evolutions, what we are studying today, this competitive gap will be building up. Any system which has got energy, it will be building up this gap. And this is also in the gap between the existing one and the transforming one. So the transforming one will be attracting the previous one to jump ahead of the existing. And then the steps are building up, so it will go on and expand more. So the measured services, actually the services what the cloud can offer, it should be measurable and committable. And definitely when it is committable, we will be able to pay the money actually. The business can take around the computing resources. So control and optimize the resource using the metering capabilities. Resource usage can be monitored, controlled, and reported, providing the transparency. The transparency must be there because when the things are bought by us and we are using it in the enterprise, we know that how much we use, how do we use. But only problem is that we have invested $1 trillion or probably maybe, $1 million. We have invested $1 million and then we are actually getting the returns over a period of time, not immediately. Here we are not going to invest, so you will see the beauty of it. So definitely we look into the service models and many of these things are well discussed actually in various places and in the various introductions. But just we have to look into, because when I am transmigrating, these are the 3 aspects on which I will build up the transference from my company into the cloud actually. I will make use of the cloud infrastructure as a service, cloud platform as a service, and cloud software as a service, and various other services are there. They are the hybridization of many of these 3 things. But when we look into transferring the enterprise computing, which is actually I'm concerned with the hardware that I bought, I'm concerned with the existing software I have, and I am concerned with the software what I have to develop because of my business process is transforming. Every year there is a transformation in the business process. So I have to develop new software. So these 3 things are actually touched upon mainly by these key aspects. And deployment models, how do I deploy? Do I want to hold everything to my chest as a private cloud and nobody else should touch it? Do I want to do it? Probably in the beginning, this is what people may do. But I'm sure that as the evolution takes place, we will be able to make private cloud inside the public cloud. So that's already there actually because virtualization has hit a big success story for the last 1 year. So you are going to see many of the models actually capable of meeting this. And the community cloud, birds of the same flock, same feather flocks together. So we will be able to get a few other guys who would like to see the petroleum development company, for example, if you're talking about. So the supply chain management companies and the production company and the sales outlooks actually can all link together and we can form the cloud. Actually, a community cloud could be formed. So the buffering, stocking, transportation, everything we can handle in such a way that I get my profit, you get your profit, and the final guys get what their share, what is actually due for them. So I can go for a community cloud, which is actually petroleum cloud. Or it could be actually a supply chain management system, which is actually managed by Walmart. So another one is the public cloud. The infrastructure is made available to the general public, a large industry group, and it's owned by the organization selling the cloud services. So anybody can hire it. University can get in, and a transportation company can get in, or it can be a health services company, probably no. health services company, no, so I'm sorry. Actually, but general companies can get in and then make use of it, compute it, and dispose it. And the hybrid cloud infrastructure is actually a composition of two or more clouds. Actually, private cloud making a coupling with the public cloud portions, where I want to take some of the aspects of the production or the agricultural production of a country. So maybe I can make a coupling, which I will be showing actually. A coupling, I will transfer the data, so the private cloud is attached to, so the public cloud is attached to a private cloud, make use of the private cloud, withdraw it or dispose it, and then I become actually self-sufficient, and I go and again go and couple it, take it. So like that, we can hybridize the thing. It can be between the private, the community, and the public. So we can definitely do that. And that will support the architectures what we are actually proposing for the enterprise computing. So the enterprise systems, we have to have a look, because we are ready to migrate. We are happy to transport things into the total cloud system. So an enterprise system provides proper abstraction. There the issue starts actually. What proper, which way proper, you can see many of the diagrams what we show, which are actually trying to define how it is proper. So the various business process translated to software and provide accessible functions for all units of organization. That's what it is actually. We were continuously refining these aspects and made the existing enterprise computing. So it's so wonderful, actually it is working fine. And only problem is that when we are transferring it into the cloud, where all the systems will be actually absolutely mapped properly, so that we get the assurance what we are getting today, or maybe a better service because of the speed, and because of the lesser cost, and because of the better security or lesser security. It was a debate, but we are convinced today that we can have the enough security. Okay, so traditionally these ecosystems were created by the in-house infrastructure, which I have talked to you enough, actually, and mostly called for organization-specific infrastructure and software architecture. Then we want to make actually the enterprise computing. We made it, and everybody is using their own. Actually, every time whole system was framed into enterprise architecture. So business process and the architectural format translations, and then we get the enterprise system and we institutionalize it with our own hardware, and then we made use of it, and then we are using it today. Well, so the enterprise architecture we are looking into, definitely we have to translate this into the cloud. So the computing portions and the enterprise architecture portions we are actually going to merge. So the enterprise architecture will be looked at, so the architecture itself and the segment architecture and the solution architecture. So various aspects of it we have to list down: scope, detail, impact, and audience. And you can see the way in which it is actually the functional process will be at the user's level, and the enterprise architecture level, agency organization will have the higher scope. So similarly, the impact will be actually at most strategic outcomes and operational outcomes, users and developers level. So the impact will be lesser. They won't feel it. But strategically, if things are not properly implemented, you will get it in the strategic slippage, right? So we get into that, and these are some of the measurements. We will be Sackman's framework. So anyway, this is actually totally a heavily discussed unit. For many months it will be taught in the universities. So when we get into all these models are properly mappable, it can be transformed into cloud computing. Let's look into actually we will be asking the questions actually what, how, where, who, when, and why. And the answers will be giving actually the why means it will motivate, and then when it will give the time, and the people will be given the who analysis, and the network, and the function, and the data. Data will be defining actually the functional enterprises. Data will be enterprise, and functioning enterprise will be giving the data. And you can see that. So the Sackman's model will be giving a parametric analysis of the whole system, by which the things become very clear. The question is that whether should I hold this or not? The solution is we have to hold it. We cannot change things to make it suitable to move to the cloud. We have to hold it, and if there is any clash coming, resolutions are on-demand resolutions have to be arrived at and solve it, and then only we can migrate it. and TOGAF, actually, the technical architecture for the framework for information management. So even that structure also will be showing you the methods by which refinement can be done on the smal model. So this is the detailed analysis of it. Well, to contain the time, I'm just moving. Advantages and challenges. So the advantages are many in the enterprise architecture with respect to current situations. If we are moving like this, totally believing the thing, because of the security aspects which we will discuss later, so everything looks to be all right. My analysis also finds it suitable for implementing in the cloud architecture. So what do I do? And my benefit analysis, where does it lead to? So the in-house control on software, high availability, all these are the aspects what is available today. Okay, all these aspects and how it can be mapped into the future purely cloud-oriented. In-house control on software, high availability of the corrections and business upgradations. Whether if it is the cloud, can I do the corrections in the maybe the hardware architecture or the communication systems with which I have coupled many countries and many subsidiaries of my companies? Will I be able to do the way in which the communication has got a typical mapping with the software when big companies are concerned? The way in which we adapt the data and then couple the data and take it, it's not purely on the computational aspects alone. So will it be supported by the future ones? Higher faith on systems and security monitoring at the highest levels. Will it be giving equivalent security? So visibility of maintenance and self-evaluation of the bottlenecks. There are several bottlenecks even today's enterprise computing. Breakdowns onwards to security breaches to data losses to and asynchronous data management situations as far as we are concerned. The petrol prices in one part of the world one way and the other part of the world another way. So desynchronized situations are there. Anyway, that's not the issue for everybody, but still. So the visibility of maintenance and self-evaluation of the bottlenecks. I'm properly in a position to evaluate what's happening with my enterprise computer system by which today how I'm doing. The capital investment is from me. I've spent the whole money for it. And everything is under my control. If anything is not working, I will be able to find out what's happening there. And there are people to do that job and tell me. And when I'm borrowing things, if something happens, will it be transparent to me? This is what happened. So, well, there are a few doubts over it, but we are improving the SLA, actually, service level agreements, and incorporating this parameters into that, and the process is going on. It's probably maybe a never-ending stream. So, downtimes and downturns. There are downtimes with us also, even though we have invested heavily and we have employed people, but still there are downtimes. And then downturns also. The whole part of the software becomes junk. And I'm no more in a position to make use of that business process. Or my business process is drifting by itself because of the profit competition I have, or the competitive position I have. So the software has to drift along with the changing business process. It's like bacteria and amoeba sometimes. So what happens is that to catch up with that, so there are downturns in my software and the spending what I did. So how can I meet in the cloud? So these are some of the questions which I have to. However, disadvantages were inherent actually. The enterprise computing is squarely facing challenges in few domains like initial huge investment. So I have talked about these are all the faith factors, or everything is under my control. Today's enterprise systems. But look at the disadvantage I have. So I'm a prophet of cloud actually. So it must be available to everybody by maybe within 10 years at the fingertips for every aspect of it. Maybe whether it is Internet of Things or Things of Things. But it must be available, the computing power, maybe a teraflop for an ordinary guy to play the games. It must be available at the fingertip. That's one of my demand. So I definitely support this. So enterprise computing is squarely facing challenges in few domains like initial investment in infrastructure. And the competitive positioning is becoming every 2 years bad. That's why millions of dollars every corporation is actually spending to give the improved order on the infrastructure and on the software. So one guy will improve, the other guy will go behind. And when this guy is improving this guy will go behind. So this build-up is there. So where is it getting affected actually? Enterprise computing is squarely facing those challenges. Which are the challenges? Infrastructure, continuous threat of obsolescence. That is too much actually. Losing competitive edge as time moves on, which I was describing to you. And specific platform-based software development and its upgradation and reconfigurations, limited virtualization. So the virtualization is limited to the infrastructure what we have and the software components we have. We can pick up things only if it is available. So the infrastructure available is actually a dedicated set of infrastructure maybe acquired for the last 5 years, which I can put it into virtualization and I can make use of it. But in the cloud, we have got a larger arena, actually a spread space, from where we will be able to do it much better and we will be able to migrate, provided the issues are fully sorted out. So the maintenance of real and virtual resources of software edifice as well as the hardware edifice. So that's another point. Maintaining the global communication and systems coherence. Heavy in-house overheads, actually. This is a difficulty. I told you, maintaining the global communication is a big problem for the petroleum companies and in the gold sales and so many. There are dynamic business processes are there. All those people will have this issue, but it's not very general though. Okay, system coherence. Actually, system coherence is a big problem if you are globally operating. So the things will be changing and then make it coherent and the delay times and many of the aspects of it actually. So, and everything is actually manageable. Then, unmanageable thing is there, everybody has to admit, whether it is Walmart or whether it is Aramco or whether it is Shell, we have to admit a fact. I have to maintain a big HR, human resource, for the enterprise computing to be live, active, and rewarding. If the guys are leaving or the novices are coming in, there are fluctuations in the operations. So, the maintaining the global communication are heavy in-house overheads of maintenance, overheads of development, overheads of operation. Everything is too much actually with the enterprise computing of the current trend if it is maintained. If it is handed over the whole thing, the HR will be actually professionalized HR which will be maintaining the cloud. I am using only the resources. To that level it will become better. So, do we have to have all these challenges continuously? This is the question which is going to motivate the transfers of the enterprise computing totally into the cloud, which is anyway going to take place. Well, that makes us to think actually the changing game of mission critical enterprise infrastructure through the cloud. So we have come to the point. So the enterprise cloud, so it must combine the power and flexibility of infrastructure as a service with the expertise, security, and availability that large organizations with mission critical computing needs are there. Why I took mission critical computing actually? If the mission critical computing requirements of the enterprise is met, the rest of the things can be met easily. So let's talk about the major demand and then we will get it. Allocation of the computing resources when and where they are needed. So that's the point. So at one side, Shell may be required to make use of the heavy computing requirement to be derived out of the cloud, and Walmart may be, and Amazon has got its own, and they are actually professionalizing into the world of computing using the cloud techniques what they have because of the data center they have. But the repacking of the data center and reselling, it is going to end. The graph is like this on decline, and it will come to zero shortly. We have to have professional clouds, which is absolutely reconfigurable, upgradable, and disposable. Though people claim, still there are actually sanctum sanctorums of the past, actually hidden inside the cloud. So, allocation of computing resources when and where they are needed. Manage associated PMS as the multi-tenant format. Multi-tenant, of course, many people want to come in. And the whole cloud will be a mapping like this. Look at that, P11 to P1N, and then PM1 to PMN, and then, of course, this is actually one-to-one mapping. These are absolutely flexible numbers. Don't take actually M and NS as a rigid structure. If they are actually, first can be MN, and then PQ, and then it could be RS, and then it's all flexible dimensions. It's not the same, but the easy to understand format is this. the final clouds will be a cluster of these things coupled together, and I will be able to form the matrix. A small processor unit will be demanded out of a small cofactor of it, or a small matrix of it. And then that will be coupled to a large matrix because it's a memory oriented, and it will be coupled to a big storage. Otherwise, if it is a scientific computation, sometimes the processor demand will go up and the memory demand will be remaining same, and the storage, I'm not going to store anything further actually. I compute destroy because it's an iteration, numerical iteration I'm doing over the probably a numerical solution for the atmospheric stability what I'm doing. Maybe actually a simulation of the universal evolution. So I may not be storing all the computations. So different architecture can be formed because of the TMS matrix. So let's have a look at the theory. This is the theory we will follow, and how people can layer it. So this migration will demand, and the companies are tending to support. How do they support it actually? Network switching and the firewalls and the hardware load balancing techniques and the processing, storing and memory. We will layer it. And then we will be getting the global data centers which are actually supporting this structure. We will layer it across the world. So one in Hong Kong, one in London, and one in New York, and then one in California, and then one in Canberra, one in Bangalore. Like that we can couple it together and things will be made available. And the network service providers like these people will support them so that enough bandwidth is obtained. So then the issue comes actually about the enterprise cloud. I started calling enterprise cloud actually. Enterprise cloud security, as if it is actually enterprise has completely moved in. But it's an issue which has to be resolved, and it will be continuously resolved. So security is a security. Security is a pure secure system until and unless a vulnerability is exposed. So we believe in security all the time. So it is secure until the vulnerability is exposed. So like Machiavelli is told, politics is a politics as long as it is not seen or visible as a politics. Every politics is failing in the world because it becomes explicit. The best politicians are not known as politicians. And they got their things done. Security is also like that. So until the vulnerability is exposed, everything is secure. So believe in that. So I called enterprise cloud security. Fine, let's go ahead. So the enterprise cloud must provide multiple security standards at different layers and the optionality to escalate and relax levels of it that the enterprise model demands. This is the question. Does everybody need the same level of security? Do you think so? Are they using it today? No. There are people successfully operating at lowest level of security, and they never have a threat because even if their data goes, nothing can be done. Because there are nobody to see the garbage collection agencies of corporations. They have got about more than 200, 500 trucks holders are there actually. So nobody is competing with them. How many trucks have failed today? Nobody is probing and then hacking and taking it, and then, okay, out of the 250 trucks operating in the eastern region of US, about 50 trucks have already got stuck up. Nobody is bothered actually. Today 50, another day actually maybe 100, half of them are not operating. Nobody is bothered. But if a single transport ship is stuck somewhere in petrol, a delay of actually 5 hours or more, it affects the price. You may be getting short. So who is monitoring? Everybody is monitoring. Where the ships are going, how much offloading is there, how much transference is taking place, everything. Not only this actually, even the air transport systems, how many planes are operating in which segment, everything is continuously monitored. So the point is that the data, the validity of the data. We are talking much about big data analysis these days. Actually, every data is not big data. Every data could be big data. But every data cannot be valuable data actually. And the value, as far as business is concerned, where the profit is attached. If the data can be transformed into profit, it has got high business value. If the data cannot be 50 trucks have actually got spoiled, you can start collecting the garbage, nobody will decide. So nobody is bothered about that 50 trucks are not operational or not. So maybe somebody who is planning, and my life is going to be garbage collection and I want to form a company, he may start monitoring, maybe one guy. Not 200 guys, looking at how many are actually failing every day. People are not looking at. So the value of the data is actually how much profit it is going to yield. So anyway, that's not our interest, but I have to tell you. So the multi-layer approach to delivering security services enables the customers. So in fact, security, every security for that matter, the security structure of the present computing thing, what we are doing, actually it is under evolution. You might have read all the papers. So we have to have the layered security and lock and key with every aspect. A user login, definitely it was there. And the physical security we have given even for the PC onwards to the evolving network, whatever we had security. But when it comes to interactive, high-level software security, what we imagine, we require lock and key at every place. We have to have the gating systems. We have to have the control and reporting for the process. And the process cannot be managed the way in which it is done by the Microsoft. I'm not anti-Microsoft, but I'm telling that it cannot be managed this way. We require better operating systems with lock and key at every process, and identity is required. How the process is mating with another process. So, and then I have to have the identity of the both, actually, what they exchanged. So in the communication also, 21st century communication and the process management of computing will definitely have to have, I would say, the security systems redefined and personalized. So, like the human being actually, we identify each person and a big process goes on when you are meeting your friend A, friend B and friend C. And for A, for B, for C also. So, we have to have a big database behind it when we are transferring information. And that is cognitively done by the mind and then doing it. So this process is not taking place in the computing systems. It is actually defined by us in the primitive way, whatever we could perceive, and it's going on. But a transition from there to high security systems of multi-level lock and key will be realized in this. And people have tried, and it's giving good returns these days. So they decide state of protection at all levels within their enterprise cloud environment. We want to see that the lock and key is working properly. If you are the person, or if you are the process, or if you are at the right time, open. You interact, take data, process, and go back to lock. So this process will be taking place temporally, spatially, logically, and coherently. So this type of improved logic and improved security is required, and it will be implemented. It's a complex process because cloud is taking every aspect of into much complex domains. So in the parametric domain itself, actually, of the order of a million processes we have to manage. But virtualization will be definitely giving a model by which I'll be able to control the finest threat to the integrated threats of millions. So multi-layer security services can be delivered in the cloud to help defend your websites, applications, and data from malicious attacks by combining the most advanced state-of-the-art tools. Services. Actually, when a good security comes in cloud, actually attacks will come down because the security itself becomes so complex, this fellow has to struggle for 25 years. And the cracking operation by an organization, it has to spend a lot of money and invest. The capital investment is required for cracking it. But today, capital investment, you know that you have a PC or a laptop or something, and you have the basic knowledge of the potholes of Unix system. Then you can do many things even today. So, same thing will not work here because we are going to have complex lock and key and then mapping and then a Hilbert space paradigm in which the transformed parameters will be extracted. Which these things are not met, it cannot further proceed in the other operations. Anyway, it will take a little bit of time more. So, state-of-the-art tools, services, and instrumentation, and all managed by a team of trained, experienced, and certified security professionals. This has to be provided by the best cloud providers of tomorrow. So it's a job on them to convince the enterprise computing to move it. Resource pools, actually, this enterprise cloud, how they will be demanding it. ECA actually is based on cloud concept of pools actually, and then the burst mode. These are some of the aspects of it. Actually, I will be having a demand protected to them. Sometimes what happens is that if the market is crashing, I have to do several computations from different parts of the world. So I may have a burst mode. So normally the curve will go like this, I will be operating at this. It may burst and then it may come down or it may remain there. So the burst has to be met. in the computing side, and then virtualized machines, virtual server technology, robust and secure virtualization, we have achieved many good levels by this time. Role-based security, actually, create user accounts and provide access to their systems of the enterprise cloud, set, define, and revoke user roles and responsibilities. This also we have achieved, actually. Many of the companies have come and advertised, and convincingly they have made demonstrations to me recently. So there are companies coming up, but enterprise migration still has to take place with all these features. So high performance storage, definitely there are breakthroughs here. Actually, we require, actually, enterprise cloud provides a dashboard of total discount for the year, so that you know. So what I need to say here is, actually, redundant high performance fiber attached storage architecture is available, and it can be in terabytes to petabytes to multiple petabytes, and reconfigurable. That means a smaller scale person or smaller scale enterprise to large scale enterprise should be able to extract from the same resource. So for that purpose. And then intuitive web-based control must be provided for the cloud computing. So intuitive means when I'm actually generating my enterprise cloud architecture and enterprise cloud computing, it must be much more intelligent than the way in which I was doing in the past. This is a basic demand we have put forward, and people are actually making tools for it. So a dashboard will be there. I don't have any infrastructure in my company. This is the problem. I have only few consoles by which whole computing is reflected into my company campus. And the whole software is somewhere else, whole hardware is somewhere else, and the whole control is somewhere else. So I have to have the virtualization properly coming in a web-based model by which I will be able to achieve it. So finally, end-to-end security. Every data I transport from my collected information of the business process towards the processing center and back to the user and decision-making authority, the loop of security must be end-to-end, fully secured one. So definitely the security services, actually, all the listing is there, actually, firewall to intrusion to logging, all the concept has to be properly translated in certain cases. Encryptions, and then manage the file integrity monitoring, and manage the scanning, manage the flow, aggregation, all these things. Several people have attempted, and there are tools available today. It's under testing now. So the enterprise class features, actually, enterprise class agility, the way in which I can change things depending on the business process migrating. And the enterprise class resources. The resources must be actually resilient to pitfalls, actually, and damages, and so many other aspects. We call it as resilient. Actually, CPU, memory, and storage built on a widely scalable, exceptionally reliable computing architecture has to be ensured, and we have to do the test running to prove that our demand is met. Enterprise class control, so the absolute control of it, because actually many of the CEOs are very paranoid about the computing, what they themselves do. They believe that something is happening, this is what they believe. That makes them actually very conscious and try to do things much better than they did yesterday. I'm not actually telling that this is a bad habit. To some extent it's a good habit by which they are conscious about the pitfalls. So same thing, actually, enterprise class control, it must be available there. Manage applications in the cloud as if they are running locally. So my visibility and my control over it must be absolutely excellent. It cannot be under the will and pleasure of the cloud provider. And using familiar tools and processes in a single integrated environment, I must be able to do it. Cloud resources to become part of the enterprise infrastructure with external resource pools appearing along the inside. So it becomes so friendly to me, and it's handleable, and it makes a feeling to me that it belongs to me. So that is slightly missing. The cloud into enterprise, whether the enterprise into cloud, whether the cloud into enterprise, it's a really an arbitration is going on. The liberty and the cost reduction are the main attraction for the transition. So the whole computing is arriving at enterprise desktops as a service. So now it will come as a service, and my software will be run there, and I will continuously use it or intermittently use it again and again. A service on demand. There are various avatars of cloud as software as service. So much more differentiated avatars will be there. So extended frameworks are there. So this I have talked briefly. And then the cloud service management will be there. Cloud consumers and cloud brokers. When the cloud is so much spread, we will have the brokers also. And they will be managing these things actually. Business support, provisioning and configuration, and portability and interoperability. And the service developers are there and service users are there. So they will be actually integrated at business levels, the service fabric, management service fabric, infrastructure service fabric, and IT infrastructure providers actually. They will be providing this, and then these layers will be there. So both sides I will be able to understand and then make use of it. And these are some of the successful things. I'm not supporting any particular company because you know the image factory belongs to XYZ company. I'm not supporting it, but looks to be theoretically matching with the requirements which we have projected from 2008 onwards. So the system engine will be there, an application engine will be there, and compute resource management will be there, as I said in the past slide, and the infrastructure services will be running in this way. It's a very detailed architecture, and then we will try to couple one to another. So you can see actually the centralized inter-cloud union. Star in a cloud we can form, cloud A, B, C, and then star it, and then P2P we can achieve there. That is actually much more faithful. I told you, we will go to the private cloud and take the data from there, and or we will give a part of the data to the public cloud, we will do the computation there, take back that. Even if the data has got little security problem, I'm not bothered. So mixing, hybridization will take place, and the multi-cloud service actually, it's a cloud bunch, and then the client and multi-cloud library and all of them sharing it. So these are some of the network architecture coming into the integrated models. Well, this is the way we will do the inter-cloud integration in the future, and then we will have much more power. And issues and challenges for enterprise cloud computing, once more looking into standards and common interfaces for the global clouding. Please bring it up so that we can faithfully interact with all the guys who are offering the services. It's not there much. So the data management and governance, and we have to have standards, better standards of it. We have written to IEEE, and IEEE said that they will look into and then form a committee, and at what time I do not know. Service management and then the governance. This is actually, we require business people also to be involved in that, and all the CEOs, their consortium. Everybody has to get into, because all the clouds should reflect across the world the same. We cannot have HP cloud, and then we cannot have Amazon cloud, and this cloud, that cloud, and everybody in different way. So we require unification, product and process control. We must have the same tools and practices, okay? So the system reliability, visibility, and availability, the measurement system must be the same. And information security, process security, and communication security, we have to have standards. So these things are definitely a challenging field. And transitions of enterprise computing to the cloud, of course, enterprise architecture, these things are definitely, we have discussed about it. The fate of banking. Even if I am telling that there are security issues with the bank where you are putting your money. Not only because of Lehman Brothers alone. Even for every bank there is a security problem, but we believe that, and then we give there, and then it works well. So that security level or the faith level has to come up with the cloud too. Establish clear connection between different enterprise architectural features and cloud, like business applications, data and technical architecture, and the cloud environment. So we come to a point of clear visibility as far as a corporation is concerned, or an enterprise is concerned. Move from the desktop and occupy teraflop computing power with petabytes. This is the gain. The most beautiful gain is actually you have got the low computing end where you are actually investing, and you are getting teraflop to petaflop to peta storage. So that level thing is coming and reflecting, the computational results is reflecting on your consoles. So, and big data using already proven software and services. And that's another beauty. It has been tested and proven by many. It's available in the cloud. I make use of it. I get what I want, and in the most secure way. Exclusively for me, from the cloud it is coming. My investment is pretty low. And I can make changes every 6 months. No infrastructure capital investment commitment. Wonderful. So these things must happen. And in which way you want it to happen? We want it to happen all in days, not in years. Because we want actually things to happen in the world of cloud in not taking years, so that the transition will be in a proper enthusiasm, and rewarding situations will be existing between the computing community and the business community. So the business community get the strength from the computing community to enhance their business process. So that should be assured by the cloud computing technology, and we have to work for that. There are several issues behind these slides. Everything we can transform it into a PhD. So that way, it's a glorious field, and people can look into modern theories of EMS matrix and things like that, and modern computing process coupling systems we can create. It's a wonderful working area, and it's going to be rewarding also. Much highly paid people will be actually going to deal with cloud and enterprise. So with these few words, I conclude my speech here. Thank you very much for the patient hearing and excellent facial response. So if you have any questions, I'm happy to answer a few, provided the moderator allows the time. Thank you.
Okay, questions, please.
Your presentation sort of points to the need for a service framework, a proper service framework to really get the whole thing going. Do you see movement in that direction? Do you see?
There are very strong movement actually. The consortiums of the companies now sitting together and thinking too. But no, the problem is actually behind every thinking there is a profit motivation, which is actually very personalized, like 20th century. Now what we are professing is that the technology, science and technology of 21st century will move to better standards and better dimensions only if we collaborate and share the profit, not greed the profit. This is one of the bottlenecks what we find.
Enterprise companies such as banking, it goes through the private clouding, not public clouding, because of security or something as that. But do you mind the enterprise company go through the public, for example, Microsoft Cloud systems? Or?
Oh, no, I'm not professing anything. Actually, I have got my own doubts on the security, because we know what security we are implementing today. That's why we are professing actually the security has to be much better lock and key. Even the process, the process when we are actually, I'm actually syncing a processor or actually spawning a process, it doesn't have a better identity by which, the whole details of security is not attached. It is still primitive of 1967 or 1975 or something like that.
Also,
they're not happy with that. I'm not telling everything is good.
Sometimes in a cloud system, sometimes you enterprise thinking about, sometimes they will not get an access for their data. For example, for any disaster problem in the country that the cloud on it. For example, our cloud system I know that Microsoft Cloud around the world, but it is not guaranteed that the data will protect from any disaster problem. For example, a natural disaster in those countries.
Absolutely, absolutely. That's why the cloud definitely will depend not on one geography. It will be multiplied and multiplied. It is actually it's a transmigrating network storage architecture actually.
Did you mind when all the companies goes through cloud?
This perfect cloud, we are expecting the order of 5 years at least a model must come in, so that but today everything is actually personalized. The company is personalized to their cloud.
Virtualization,
Virtualization is a good idea actually, and the VMware is doing good, I agree. But at the same time, those people really making use of and integrating into cloud, they are not following all the things. That's why we are calling for consortiums and standards.
Also, maybe there is a social problem with the cloud. Some people will lose their jobs.
Losing job, we have discussed actually. Recently there was a webinar, and then we had a strong discussion on that. I was proposing actually it is not losing job, actually reorienting the job. Those people who are doing the enterprise, they have to reorient to the cloud enterprise work actually. We require people. We require people to monitor, do the things, everything. It's a reorienting. No, the same claim was there in 70s, 80s and 90s. When the computer applications are too much into the business process, people may lose jobs, but they never lost. They got retrained into doing along with the IT.
Yes.
So same thing will happen in the cloud side also, I hope so.
Yeah, thank you. You mentioned something about regulation of or standardization of the cloud computing. Would you see taking the lead in this? Is he, I mean...
That's the issue actually. There's no leadership at all. Actually, the leadership has to come from the standards committee or the professional committees. Professional committees, when they call, all the companies are not participating. There are issues actually. Because if, like, intelligent networks, today's networks, we were discussing about 2 months back. Today's network is a primitive network. Even the layers are so primitive, there's no intelligence in it. But to change, who are the bottlenecks? When I was actually putting the cognitive router, there was opposition for the patent itself in 2007-8, one of the biggest companies. So the trick is that they don't want to expose or their production lines to be stopped before the profit reaping is over. So they were working against technology also. I'm not telling who it is, but it's a fact. I have proven I got the patent much before actually Motorola in cognitive router, first patent in cognitive routers. So, but the thing is that, intelligent networking, it's a big issue. We have to move. We cannot do the switching by manual intervention. When I release a message, this is not cloud actually, since we discussed, I'm telling you. When I release a message, it must reach the destination by all means. So the message must be aware of the environment in which it is moving. And the environment must be aware of the message is moving. That is not taking place today. It's a primitive network, even though we do excellently. Bandwidth increased, so the primitive systems or the architectures are still performing to the required levels, barely. But we are talking about 7.2 billion people getting crisscross connected, and their average requirement of about 1 GB is ported accurately from one point to the other. Who will do it? Will these companies opposing all these things and then their production lines need to sustain for another 5 years, will actually support the transformation? They won't. There is a problem actually. These business problems were in the past too. Unless a new company comes and then puts this forward and proves it, the professors who are actually making the theories, we will be stuck.
Just the last question. So,
one quick question.
Yeah.
Thank you, Professor. You've thrown a lot of big lights on enterprise.
Thank you. Thank you.
Yeah, and I've learned a lot. But you mentioned about low virtualization as one of the challenges.
Low virtualization. Yeah.
Yeah, but we've seen social cloud experiencing a lot of virtualization. So are there any security mechanisms to ensure, to enhance the security of social cloud?
Oh, security of the social cloud actually.
What do you recommend?
Yeah, well, the security is actually a coupled oscillating system. One side becoming better, the other side becomes totally loose, security doesn't exist. So in the social cloud, what happens is that it's for a social purpose the cloud is formed or the data is exchanged. The party who generates the data need to be conscious about the security, what's available to him. If he is within the framework, if he is doing, it's well and good. Like the market prices or what's happening in your company, you cannot announce it through the loudspeaker for your friend who is standing on the other side. You have to privately communicate to them. In the social cloud also this problem is there. Much of the privacy is not maintained in the social cloud. If that can be maintained with addressability, social cloud also can be absolutely secure.
thank you. I meant to ask, I mean, like we've seen the .com boom and the other buzzword before it. What's the future of cloud computing? I mean, is it going to be just enough of hype as buzz before it, or what should we expect?
No, it's a natural transition as far as intelligence is concerned. It's a natural transition of integration. And after the integration, I feel that there will be a disintegration also. But today it is in the integrating phase. So the integrated resources will be there, and it's shareable, and on demand it can be used. It is a requirement. We cannot continue to move. All the laptop companies will say that the cloud is not good because they have to sell it to each home. So they will say that. But that doesn't work. Now we are telling your laptops will be coupled to the cloud, and you can get terabytes, and then you can have actually petaflops right away on your small one. So the purpose is actually large amount of computing as a resource for humanity. If you are looking actually in the evolutionary scale, when the human being became much better than the caveman came out and started cultivating, he had intelligence tools along with him. He had his own associates. That means 2 people or 3 people think much better than the 1 person. So that technique he applied. Today I am holding my 2 computers here, another computer in the back, another computer there, like this. I'm augmenting around me with the data and then processing power. So that attachment of intelligence, external intelligence to the internal intelligence, it's a process of the species. And this crowding will take place in the intelligence. It's not by shaking hands now. We need not sit in London to work together. So we can work in different parts of the world and integrate in intelligence and do it. This is a part of that force, and it cannot be stopped.
Thank you.
That's it. That's the point.
Okay. Another question? No. Thank you very much.
Thank you.
5 plus what?
Yes. And I guess that's all we have for this conference. Thank you for staying, patience, listening to presentations. I hope you will have something to take with you and further your research. Thank you.
A lot of research points are there. Sometimes we are telling that research points are not available. If students are there, please look into all these things. You can open up avenues. New points are there actually.